Hello, my name is Daniel, and today we are going to do science. Not actual science, but sort of computer science. We're going to do engineering. That. Uh, so specifically, this is hopefully going to be the first of about 10 tutorials that I'm going to create remotely for this quarter's programming workshops. There will also be the normal Intro to Unity workshops going on simultaneously, but these are going to be a bit more advanced and hopefully focus on some tech art topics. If you've ever wanted to learn how to use the scriptable render pipeline, if you've wanted to learn how to do VFX, implement Bloom, learn how to write shaders and compute shaders, then hopefully you'll be able to get a lot of that from this video and this quarter. So without further ado, let's hop into things. This entire project and many other links are going to be included in the description. So before doing anything, make sure to download or clone this project off of GitHub. When you clone it, you're going to have a finished scene and a starting scene, or at least not a starting scene, some assets that I'm giving you to start out with. Right now you can see this finished folder is empty, and we're going to be filling it up. So you are going to have this already included, but I'm just going to drag it in so I can have the same starting point. Just gotta wait a second for Unity to do its thing. And you'll see there's actually quite a few scripts in here. I did not write all of them. Some of these are examples. They're linked in the description as well, that I took from either random people's projects on GitHub, Stack Overflow questions, official Unity examples, pretty much anything I could get my hands on. Because URP is documented but not well explained. So learning how to do the fundamental stuff is a little bit tricky, but it is definitely worth it in terms of performance. My computer without URP would run this scene at roughly 200 to 300 FPS, and running in URP, I run it around 800 to 850. Or at least the final scene that we'll hopefully create. You can do similar things without using URP, but it's much less efficient. And we'll get into why that is as we complete this. So, enough jibber jabber, let's get started. So some camera settings you have to make sure are good to start with. I mean, this one's optional, but I hate it. So I just use black as the background. We need HDR to be on. So that is in our pipeline settings. So if we go to our project settings, by the way, this project was, if you wanted to get to this point without downloading everything, just use the URP template in the 2019 long-term support. And you'll see we have here our high-quality render pipeline asset. And if we open this up in the inspector, we can see we have HDR checked. You want this because without it, otherwise Bloom won't work. And today's example is going to be creating a Bloom post-processing filter using compute shaders and injecting that into the scriptable render pipeline. So we have HDR on, and that should be good. Oh, other thing, we have to make sure anti-aliasing is off. I'll leave it on for now so that we can get the bug when the time comes, and I can explain why it has to be off. The answer is because Unity is bugged. But for now, let's use some of these things I included to get us a scene. So if we go into utils, we have a bunch of simple polygons that I made in Blender a while back. These are just going to be included. Funny enough, you actually can't upload libraries of simple polygons to many places. All the asset distribution stores hate them. So I'm just going to drop this in here. Let's center that. Actually, let's get behind the camera too. And I want it to be a lot bigger, so let's make it 10 times as big. And not quite as, well, yeah, why not? 10 times as deep too. And right now it's really freaking ugly, so I want it to be colored. So one of the things I included in this start folder is a script I wrote called color. And I see it has this component on it, and it has an emissivity. So let's just make it green. Oh god, that's very green. Turn that down to a 1. Please. Let's change that. See if I can get that to 0 if it makes it look any less intensely neon. Range 10, please. Yeah, nope, that doesn't affect anything. Okay. Oh wait, maybe because I have to. Yeah, there we go. Okay, you have to change the color for that to kick in. So now we have this thing here. All right, let us. I mean, if we run this in game, we'll be able to see a big bowl. There we go. I also have this script that I quickly wrote. I'm thinking about maybe next week doing something on quaternions. Let me know in the comments if you're interested in that. But if you want to rotate a kinematic body in Unity, or really move a kinematic body, you have to tell its rigid body to do that manually. You can't call transform.rotate because that's effectively teleporting the rotation. You won't get any friction or physics with that. So that's why you have to do it with quaternions, because rigid body only takes quaternions if you want to do it that way. So we make its axis the vertical one, and we're going to make it rotate every 5 seconds. I don't know if that clockwise Boolean works. I should check that. Oh, we have an error. Oh, right, we don't have a rigid body on this thing. We have to have a rigid body. And probably a mesh collider too. Don't set it to convex because it's a bowl, it's not convex. Normally, if you want this to be dynamic, you have to, but we don't want it to be dynamic. But we're going to freeze this thing's Y position. We'll freeze all its positions. Its rotation's allowed to change. That all looks fine. That looks fine. Let's see if it works now. Right, it spins. Yeah, let's make that more like 8. And we also want it to spawn a bunch of balls. And you can see the spawn balls script just gets this prefab here, which I'd have to drag in, and creates a bunch of random ones at some position at some radius relative to this guy. So we'll spawn 25 balls. If you're wondering why it's broken in the inspector, it's because of my coloring script. And we'll just spawn them starting 5 units above and a radius of like 10. And now we have a bunch of colorful balls, but we can't move our camera around. But I have a script for that. This one, not find, I didn't put the link, but this was taken from a Stack Overflow answer when someone asked for editor camera movement in game. And then I modified it a bit so you could actually move and not just change where you're looking. So there we are. Kind of looks freaky, but that's because all those balls are emissive. So they don't take shadows because they themselves should be glowing. Side note, if you were in standard render pipeline or ray tracing in HD render pipeline, you would be able to see light coming off these and bouncing off the bowl, but Unity Universal Render Pipeline technically doesn't support real-time global illumination in like any form. Kind of sucks, but if you want that, I guess you have to use HDRP. We are going to make do with Bloom though, and it will look okay. I'll explain a little bit about HDR real quick, just for anyone who doesn't know. You can skip forward a bit if you do, but normally the screen texture here is represented as a bunch of like, say, 8-bit colors. So you have 8 bits for red, 8 bits for green, 8 bits for blue, 8 bits for alpha or something. But with HDR, instead you have 16 bits for each color. And the main difference there is that you're able to represent brightnesses and values way above 1. You effectively have floating points for the intensity of each color channel. And when you do that, you can, if you had an HDR monitor, change the brightness of each area specifically. So 2, for example, if a color had a red channel 2 on one side of the screen and a 1 on the other, even though those would be identical normally, or you wouldn't even be able to express a 2 in an 8-bit number system, maybe. You'd probably be able to express 2, but that's a bigger number, but whatever. The 2 would actually look brighter on an HDR monitor. So when we set it to HDR, we are effectively getting more resolution and more color space. And we're going to use that instead of for an HDR monitor to figure out how to simulate a bloom effect around them. So now that we have a simple, pretty-ish scene that could look good if we bloomed it, let's get to work with that. So save real quick. Let's see our project settings. So we have under graphics this universal render pipeline asset. It's just a default high quality. It has these settings hooked into it. And you can see all these different settings that it gives you, the SRP batcher, anti-aliasing, HDR, whatever. And importantly, we have this forward renderer here. And if we go in here, we can see there are renderer features, and we have none. So if we try to add one, this is from the example, the Unity example I brought in. I have no idea what this one is, but effectively, we are going to be writing something that we can put on here. Let me just see what this Unity one does, so we can see what one looks like, kind of. Yeah, Unity's going to complain, but we don't need this. So you can see you have an event here. You can see like we can what point is this render feature run? And this is all, you know, specific to this implementation. I don't need it anymore, so we're gonna get rid of it. But that is in general what we're going to be starting with. So we are going to make a bloom render feature. I will note though, if we don't screw with the name a little bit, it's very likely you have something like that in your packages. So I'm going to call it render feature bloom. Bloom with 3 M's, or 3 O's. Okay, that's not what I wanted. We're also going to create another script that is going to be BlitPass. Bloom with 3 O's, that's right. Actually, you know what? Before we get to this implementation, I'm going to show you the way you should probably do Bloom in Unity. So let's just call this volumes. It's really quick and easy, that's why I say it's the way you should probably do it. And we're going to create a volume, and it's just going to be global. Oh, yes. We're just going to create a new one. Okay, didn't need to. Where did we make this? Let's get rid of this new one. And also let's call this post-processing. And we're going to add an override. Post-processing, bloom, default settings, why not? And let's see how this looks. No difference. Why? Oh, we have to check post-processing. Does that do it? I am back. I was being a fool. So all you have to do here is click this little button, all, and then make sure the intensity is higher than 0. So we'll make it 1. And there you go. That is the simplest way to get bloom working in Unity. It's a very pretty effect. It doesn't cost too much FPS-wise. You can see we go from like 1.5 milliseconds to 1.8 milliseconds there. And that's with the stream running. So if you actually want to use bloom in a future game that you're making, go ahead and just do this. But for the sake of the tutorial, we will be making our own. Okay. So getting back to where we were. That's one of them. That's both of them. Okay. So here, instead of inheriting from mono behavior, what we want to do is inherit from Scriptable RendererFeature. Might have to do some imports for that. Okay, good, I found it. So do away with start and update, because we don't need those. So basically what this class's responsibility is going to be is it's going to make a BlitPass object, which you can see in editor is more or less, oh, well, we don't have it yet, but for example, new blit here would be like the component that we have on this forward renderer, and it passes these settings onto the thing it's going to be making and creates it and adds it to the rendering pipeline. So that is basically our goal here. So to make those settings, let's make a struct. We'll make it serializable so you can see it in editor. Let's say bloom settings. I'm not going to use that O thing inside of the script, so that would be cancer. This is going to tell it when this should be run. This is a native feature of the Scriptable RenderPass class, which is what this one will be. We're going to need a compute shader because that is how we're actually going to do everything. That's how you spell threshold. and intensity. Those are basically going to be our only settings for this simple bloom. Could maybe do spread, but I don't really want to do that right now. Maybe afterwards. If you see it in the project when you download it, I did it. This is so that it can be also seen and modified in the editor. And then we want to, this one doesn't have to be public, but we want our BlitPass. God, it has to have 3 O's in the name. Oh god, terrible. Okay, fine. I ran into a bug when I was first doing this a couple nights ago that took me 2 or 3 hours to figure out because it wasn't giving me real errors. And it ended up just being a name conflict in one of the packages. This is, oh, okay. It all did it for me. Well, this is one of the things that we have to override in this class. If we mouse over it, you can see we need to implement add render passes. I think if I deleted this, it would say we have to create two. Yeah, there we go. Yeah, that. So create is basically going to instantiate BlitPass. In fact, that's all it's going to do. There it goes. This is presumably called when Unity first kicks up and it builds its render pipeline. And we're going to pretend we have a constructor for this thing that just takes the 4 things we set up as settings. And now we have to actually add it. So the only, why is it complaining? Oh, okay. The only kind of tricky thing here is that I want to make it throw an error if our compute fader is empty. Because it's going to try and add this thing on as soon as we click back into Unity, and we don't want it to add something broken. We'll just log a warning. And actually, adding it is very simple. We need to call this BlitPass class. It has a built-in, or actually no, it doesn't. I'm going to make this. This really confused me when I was reading it in other people's examples because it's like everyone has one, but it's not actually like an overridable function. But you can see here, add render passes gives you some helpful data for when we need to set this thing up. So we are going to send it the camera color target, which is basically the back buffer texture, I think. The array of colors that it's going to be putting on the screen. So we need to do some work in BlitPass. We need to implement a constructor and this setup thing. Uh, 1 second. We also need some variables here to hold things that are going to be created in the constructor. So we'll just create the compute shader right there. And what else? What else? Oh, I think we need, no, that'll just be in the constructor. I don't have to declare that because it's inherited. We'll also just name this thing so that the profiler knows what we're talking about. And then we write our constructor. Let's see. That should be good for now. And then we'll define setup, which we were using earlier. Now we need something to hold this. Let's come over here. Let's call it camera text. Why is this complete? Methods must have a return type. Right, Rios. Yep, that we do need to do. Okay, so next step. We have two functions here that we want to implement. It makes us implement execute, but we can also implement configure, which is called right before execute with slightly different data. So let's start with configure. Wow, did it all from and let's see. Camera text for descriptor is a mouthful, so I'm going to change this. Camtext dot. This render texture descriptor. This is basically just holding information about the texture that the camera is rendering to, like the width, the height, depth, literally depth. But we want its width and its height because we need to know those things. And I will make more things to hold those. In fact, you know what? I'm just going to save the whole thing. A simpler name. Settings. And now the fabled execute method. Oh, shit. Edit that little bit out. So in here, you can see we have this. Oh, is this not the right thing? No, it is. Okay. So effectively what you want to do in this function is create a command buffer and fill it with commands that you're going to send to the GPU and then ship them off. This is where a lot of the performance increases for the standard render pipeline come from. Previously, if you wanted to do post-processing effects, like I included a standard render pipeline, not full version, but like most of the key parts of it, folder in this project. And when I had to do it there, I effectively had to call Blit multiple times, have the GPU like receive these textures, do its thing, send them back to the CPU, wait for another instruction, etc. There's a bunch of back and forth that doesn't need to be there. So in URP, you take a more rational approach to things. You queue up all these commands, and then you just send them off all at once. And the GPU gets back to you afterward. So we'll do the most basic part of this first. See, this is our command buffer, and we'll just call it CMD. And we get method. This is not getting one that already exists that's named something. It's getting one and naming it this, and we'll give this the profiler tag from earlier. Just so that when you look at this in the profiler, you can tell what the hell is taking how much time. And at the very end of this function, we're basically going to say cmd.execute. No. We take the context and we use that to execute. And then we have to release it. All right. So between these lines is where we're going to be doing compute shader stuff. So let's start basic. Let's for the URP. So to make a compute shader, you just come right over here, create shader, compute shader. And we'll call this Bloom with 3 O's. Once again, Unity, you failed me. And this is a super simple one right now. This takes this result texture and fills it with stuff. There you go. This one random number. I want to pick a number, so let's say let's do red. 0, 0, 1, 0, or 1. Or no, that would be blue. Here. Good. So now if we want to actually, use that and print it to the screen, we have to create a temporary render texture and fill and use the compute shader to write to that, and then blit that onto the render texture of the screen, which we have a reference to in camtext. This render target identifier is how we'll do that. You can't use a compute shader, as far as I know, to write directly to the camera target. You can try, but it will say that the texture wasn't created with that parameter set. So the best we can do is use a blit. Will save us a little bit of time and performance, but whatever. So let us begin the compute shader stuff. So we're just going to pretend we already have it. So compute, yeah, because it would already have been created in Constructor. Okay, so first of all, we need its kernel. We can just safely assume right now it's going to be 0. It's going to be 0. Explain what the heck I'm talking about. You can think of this as like a public static void main. This is like the entry point to the compute shader. This num_threads thing is basically just saying we're going to dispatch this in groups of 8 by 8 by 1. So 1 deep, 8 wide, 8 tall. You could think of it if you're using it spatially. So you'll create a bunch of thread groups with 64 threads in them. The thread groups, their main significance is that they share cache. You might be able to get a tiny bit more performance in certain workloads by making this bigger, like 32 by 32 or something, but not much. So 8 by 8 by 1 is fine for our purposes. All right, so in order to start with that, we're going to, let's take a quick pop over to the Unity docs. This, they have all the stuff that you can put into the command buffer. These are all their methods. And the one we're doing first is to get that temporary render texture so that our compute shader can write to something. And you can see it takes a name ID, render texture descriptor, and a filter mode. Filter mode, we'll probably set that to linear or bilinear if they have it. Name ID, shader property name for this texture. Interesting. Oh, this isn't it. I think we can just default that. All right, but the important part is that we have to have this render texture descriptor. We can figure this one out, but I bet that's just an enum. We have another one of those here, so let me make sure I have the right thing. Yep. Just like we had for settings. Let's call this temp1. That's a very descriptive name. I assume we might need that. Let's try just giving it the render texture descriptor first. Let's give it temp1. Okay. Oh, here we go. No. What we need is a render target handle. That's where it is. Okay. temp1 handle.id and temp1 descriptor. So I figure this is probably going to get written or returned to, or maybe it just has a unique name to begin, ID to begin with. And this one effectively carries the settings that we want to create it with. In fact, we might actually want to create it with the same settings as the camera. I'm going to be a little more specific with this name. Let's call this cam settings. More explicit with things. Yeah, good enough. And in configure, we're going to say ham settings dot enable random write, and we have to have that be true. Otherwise, we cannot use this thing for the purposes that we want to use it for. So now we're going to get that temporary render texture. Now let's make sure we release it. This is going to stay at the end. I'll do the other stuff above. All right. And now let's start setting the parameters of our compute shader. The only one it has is result, so set a texture param. What does this want? This wants the compute shader, so for the compute shader, bad practice, we're just going to say it's 0 for now because it's going to be 0 because there's no other kernels. Name ID, I'm going to add what this is. Render target handle, temp1 handle. Render target identifier. Let's make sure this is correct real quick. It is not. Okay. Yeah, we want this one to be a string, and this is going to be result. Because this references the field in here. So we have now set our compute textures command. Our compute shader as texture, and it's going to output to that temporary render texture we just created. Also, I should not be releasing it right before. Oh no, that's fine. Because it's a queued up command. Yeah, that's fine. And then we're going to say cmd dot dispatch compute. And it's going to tell our compute shader to start running. We're also just going to assume that's 0 for now. And I don't want this constructor, I want this. And we are going to say, let's see, and settings width over 8, and settings height over 8, 1. And the reason this is over 8 is because what this is doing is dispatching thread groups, and each thread group that we made here is 8 by 8. So we want 1/8, so they cancel out. So you have effectively one thread or one process for every pixel on this texture. The last thing we're going to do is split this onto the camera texture. So our handle is temp1 handle.identifier, and our destination is camera fence. And we release that and do that and that, and we should have something on the screen at this point. So let me not put a foot in my mouth. Should just be an empty color, hopefully. And oh right, we have to actually get into settings. And RendererFeature blue. There we are. Interesting, there's no little all thing right there. So our compute shader. You have to lock the inspector, that's annoying. Or better yet, you probably only have one in the whole project. Yeah, here we go. And you can see everything just turned black out there. Don't do it before rendering, we want this after opaques, and there we go, everything is black. I don't think that means it's good. Yeah, you can see it's complaining at us a lot. It's not created with the UAV usage flag set. Property result at kernel index 0 not set. Okay. Also, if you ever get that inconsistent line ending thing, just do that. So where did we go wrong? 1 second. Okay, we're back. In a bit of debugging later, we can see that, let's go off of upload frames. Oh, we've already finished it. Whatever. We can see that this changes from false to true after we set it. We come here, and it's false again. And that is what's causing our error. Because this was not created with the UAV usage flag set, which basically means we can't write to it. If you recall, we are creating this render texture with cam settings. So if it's not letting us write to it in the settings, it's not going to let us write to it. So we're going to just override that here. And hopefully that sticks. Now, future me speaking, forgot to mention this, you have to initialize the handle. Yeah. And we don't, I'll comment this one out for now. So we'll come back here and look at that, everything is red just like we wanted. That means our compute shader is doing its job. Where? There's, we enter play mode. All right, great. Now we want our compute shader to actually do things. So the main idea with Bloom is first you filter out the not glowing colors. Filter out then we blur them. Then we add them back to original image times so let us make some properties. Let's make a float threshold and a float intensity. And we'll also make texture 2D, also float form because it's HDR source. And the difference between texture 2D and a read-write texture 2D is primarily that you can only read from a texture 2D. You can't write to it as an array like this. Also, a read-write texture you cannot sample from. So let me demonstrate. Oh wait, we need a couple other things. We need the width and height. That way we can tell what our UV coordinates are. You see in here we have id.xy. You can think of this as effectively passing us the pixel indices in the image. Or a set of pixel indices that is going to be in the image. That's not actually really how it is. We're not married to positions in a texture like we would be in a fragment shader. But when you have effectively one process per pixel, it maps out well enough. So we are going to say this is going to source dot sample level, and we need a sampler now, but this isn't something we have to get from the script. We can just create this. So you can actually make a nice, really easy default sampler or sampler state just with word parsing. If you look up sampler state, in fact, I could show you in a second. Linear clamp sampler. This will just be like auto-filled to be a linear sampling clamp sampler. So sampler state. See, like this is what it's talking about. You can make them specific to textures, or you could put these words in them to make them just like kind of pre-made defaults. And they basically govern how you read from the texture. Is it like a point filter or bilinear or what? So it's going to be the first thing we pass in. And then we're also going to pass it the 2 pixel coordinates effectively divided by float 2 of our width by height. And we're just going to put 0 here because sample level refers to sample bitmap level. 0 is the most detailed one, and so we just use that. Fun fact, if you were to do trilinear sampling, effectively what it's doing is bilinear sampling on multiple levels of bitmaps. That's where the third tri is. And now once we set this up in our pass, we should be able to see it just copy what's already on the screen. In fact, you know what? It's a little bit boring. So I'm going to add a red tint to it. There we go. So we'll know it's working if there's like a slight red tint to everything. So we have to set more of our compute shader parameters. Int param compute shader 0 width is the field, and we'll set it to be. No, we don't have to take a kernel for that. Interesting. Okay. Seems like simple stuff is just shared. Very nice. And it's not width by width, it's width by height. Anything else we have to set? Yes, we have to set the sampler and also the result. So the source and this one does take the kernel. We're going to give it camera text as its source. So it's going to read from camera text. It's going to add a little bit of red to it, and it's going to put it back in result. And then we're going to split result into camera text. Let's see if it works. Oh, yep, there it is. Yep. And everything is Mad Maxian. Cool. So back into our compute shader. By the way, I'll just show you guys this since it's kind of useful. If you go over here, nvidia the standard library documentation. This will also be linked in the description. These are all the functions that you can use effectively. You can find a bit more details on the classes and stuff, like samplers, textures, and read-write textures 2D in the Unity documentation. So what we're going to be doing here is called a halladay blur, because it's easy and it looks not terrible. So this is a paper by Intel that was just kind of going over a bunch of different ways you can do this blur thing. Gaussian blur is kind of like the highest quality standard, but halladay blur kind of approximates it by doing multi-pass stuff, and it tends to be a bit faster. You can see the curves are pretty similar. What you don't get is this little bit of a tail way out here. That's non-existent. But for the closer parts, it's close enough. The way it works is effectively you take your texture, and in our case, we're going to create some copies of it so that we can write to them from the compute creator. And you first take the average of the immediate pixels, actually even just itself. You first just take the average of the immediate pixels, then 1.5 spaces away, and you'll notice he's sampling on the corners of pixels. This is because with a linear sampler, you can just average the pixels without having to do the computations by just sampling right in the middle. That's kind of like a built-in instruction already. And he samples them a couple more times further away, and then once even further. So this is going to take several passes and a few render textures. So let us, source and result. Let's see, not anything else here. That should be good. Okay. Oh, here, I know what I want. I knew something was there. Skip. That's going to represent the distance away that we are sampling from. Okay. Now let's hop to it. It will be this guy. Yeah, okay. Since these are basically pixel coordinates, we're just going to add the pixel offset that we want for each level. And then we will do a quick average of these by dividing them by. Let's make sure that's a float. I don't know why. Integer division has me traumatized. Would write to result the average of all of these. Also, let's rename this to something more descriptive. Let's name it blur. Yeah, good enough for me. And we have to set that little parameter now. This is going to be hard-coded. Started at 0.5f. Yeah, that works. And then it's going to take that and give it back. So let's see what that looks like with Very minor blur. Maybe it's a tiny bit blurry. It's hard to tell with such a small skip parameter. So let's make it like chalky. Oh yeah, there you go. That's kind of weird looking. Okay. So starting at 0.5. This isn't exactly perfect, but it's pretty close, I guess. We're going to... This will be our first pass. We need more render textures, so we can bounce them back and forth and do a bunch of different passes. I need to set those up so we can get a new render texture. Oh right, forgot. You need to do this. Shoot, I will probably, yeah, I have to mark that. I have to mention that earlier. So that was a bug that helped fix something. So now that we have that, let's create our new temporary render texture. And it's pretty much just going to be mimicking the camera settings. Yeah, looks good to me. Oh wait, no, we need to set it in Compute Creator. To handle. And this one is going to not be anything yet. We don't set it yet. So our first pass here effectively reads from the camera into our texture. The next one, we are going to change what it's reading from to be the texture we just wrote to, and change what it's writing to be our currently empty texture. So say, you know what, let's just copy this. Our result will be temp2 handle, and our source will be temp1 handle. And then we dispatch again. And now our, oh right, we have to increase the skip too. So on the next pass, skip is going to be 1.5. And then we do yet another pass. And on this one, it's going to be 2.5, right? Let's see this thing. So 0.5, 1.5, 2.5, and then it's going to stay 2.5 for one more, and then 3.5. So let's change these. That. again, but we're not changing skip for the next one. And one final time at skip equals 3.5. And our final result should be in temp1 handle. Let me just reread this to make sure I didn't make any dumb mistakes. Result into temp2. Looks good. This should be significantly blurrier when we get back to it. Oh yeah, look, that doesn't look terrible. That's a pretty decent blur if I say so myself. We can also save performance and get it a little bit blurrier by doing a down resolution. So if we want, we can sample the texture, or we can make our temporary textures half size. So let's do that. Let's say cam settings dot width divide equals 2. Cam settings dot height also divide equals 2. Width and height are good. Now one thing we have to keep in mind, actually no, that should work out. I think that'll just work out. Let's see. Oh yeah, that's much better. Look at that, that's pretty freaking blurry if I say so myself. What if we go down 4? Well, no, that's really blurry, but that just looks like crap. Yeah, we're not gonna, oh god, look at that, that's terrible, screw that. We'll have some of that artifacty stuff. Could also do a different pass here just for the first one where skip is 0.5, so you actually get all 9 of the ones around it instead of just the ones at the corners. I might do that in a sec. But first, let us make our filter. So we did the blur step. Now we have to do the step that filters stuff out. That is not bright enough. Call this threshold. So it occurs to me I can probably save some time in this other one here. Put that. Maybe a little bit. That's, I mean, it's going to be done like a friggin' billion times, so might as well do micro optimizations. replace those. There we go. Hopefully I didn't break everything. Alright, threshold. Okay, so let's load our color forest. And we're just going to load it at the direct position. Even do these as like uniforms, that would be nice. Or just put them in that way. Whatever. Alright, so we're going to take our linear clamp sampler, and we want XY over dims. That is effectively our UV, and 0 for the map pull. Now that we have color at that 1 pixel, we have to decide, do we keep it or do we throw it out? I'm going to say if it has any coordinate that is higher than threshold, we keep it. So result xy equals src. Now we can't do, you can do branching in compute shaders, it's just not very efficient, and there's ways of getting around it. And one easy way here is to just use a dot product. So we're going to say if this guy minus float 4 that would potentially result in negative values, so that would be no good. How about this? Step, which returns 1 when the first component is less than the second. Step of source by float 4 and we're going to take the dot product of this with just 1. So the dot product of a vector, by the way, is just a component-wise like multiplication and addition. So if we had like a float 4 or a vector 4 that was, for example, 2, 2, 2, 2, it would be 2 times 1 plus 2 times 1 plus 2 times 1 plus 2 times 1, which would be 8. In this case, since step returns 0 if this one is, is this the opposite of what we want to do? It might be the opposite of what we want. Let's see. This is the opposite of what we want to do. We want source to be the second one. That's why you talk through your stuff when you're coding. It's helpful. So when threshold is less than source, you'll get a 1 here. And the step function is going to return a float 4 because it's going to compare them component by component. So if we have any 1s in here, meaning any component here is greater than threshold, dotting that with 1, 1, 1, 1 will tell us it is bigger than 0. So to compare it again without branching, we'll do this guy, and it say some small number. The smallest possible thing we could have is 1, so like 0.1. If 0.1 is less than any component. Oh, do I have to do another dot step thing? No, that doesn't seem right. I mean, if it's one, it should be fine, right? Yeah, that's fine. That's fine. But that's not going to be a vector. It'll just be a 1 or a 0. And we can multiply one component by this guy, and it'll be bitwise. So it'll just do it for all of them. So now this little complicated line, basically saying if any source exceeds threshold at any component, that's the dot product, or rather, if that dot product is greater than 0.1, which it will be, then oh boy, then multiply that by the original color and drop it in. So this is either going to be 0, black, or the original color. Well, we can't quite see how it looks yet. That's fine. We'll create the last kernel while we're here too. Right. Copy that chunk. And this one is going to be pretty simple. This one is just right. I need one more texture here, I think. I do. I need a full resolution texture. The other two are half resolution, so I need this full resolution to be copied into. Yeah, okay. What do I? Yes, I do. Source needs to refer to the camera texture. And then I need a second one for light, and then the result will go into another temporary texture, and then we'll blip that in. Okay. Let's call this word. Say that it is equal to, and I'm going to, once again, famously copy my code. Sample at for UVs. I'll have to make sure to change width and height later. Plus intensity times the blurred one. And that should be pretty simple. We don't need the skipping stuff though. Okay, so let's go back to our BlitPass. Everything works out. I think it's actually going, yeah, I know. This one interests me. These interest me. Let's see. Here, do you have things for me? Wait, what the fuck? God damn it. It changed when I did the textual substitution, it broke this. Okay. Let's do this. Index 0 is out of range. Hey, I actually have to look at like and do find kernel now because I have a bunch of kernels. Okay. That's pretty simple. It's what's our first one? Let's do threshold kernel equals compute shader dot find kernel And let's get the name of it. And I'll copy paste it because I hate typos. We'll have it blur kernel. And lastly, add kernel. I am confident in my ability to spell that. So now in all these places where it says 0, we're going to replace that with threshold. Threshold? No, blur. Let me make sure there's no other zeros in here. There are, so I have to do it by hand. There we go. So this is the blurring step. So I need to create a big render texture that's the same size as our camera texture. So copy pasting is so nice. Cam text copy. Oh wait, this should have been a handle. In fact, I don't need these descriptors, do I? Right? Do I ever use these? I don't. Cool. Yeah, that works. Let's go over here. This will come before we divide those things by 2. Because I want this one to be full res. And after doing that, let's see. I'm basically just going to replace camera text here with camera text copy. Or actually, let's go step by step. Oh, threshold kernel. And our name will be, yeah, let's say this is the source. I haven't set threshold. I have not. Okay, I have to do that in a second. Let's see. Alright, don't have identifier. So need to set threshold. Not a texture param. What param? Threshold kernel. Don't need that. There we go. And before we're dividing it by 8, we'll divide it by 4 now, since this is a full resolution texture, and we just above divided the width and height by 2 because the other textures are half res. Why did I do threshold kernel for all of them down? It should have been blur kernel. Oh my god, I'm a fool. Alright, well, we dispatch our threshold kernel. And that is going to write to camera text copy. Let me comment all this stuff out for now, because that is going to be broken. And I want to see what happens. Also, I should have been releasing those textures. Okay, that was a memory leak. And expose. And now, hopefully, we're going to see a black screen that will go away when I make the thing brighter, the bulb brighter. I have a feeling it's going to complain at me for some stuff not being set. We'll see. Okay, yeah, it's complaining. And that just made this compiling. Okay. And it's not showing me its complaining. Which I think just means I have to... Yep, I copy pasted that. I think that means I just have to make sure I set the textures for everything. So that will be done at the top. Alright, we're back. So, I actually don't know if I need to do this. Let me check if this still works when I comment this. Probably won't. This. Okay, well, let's see. I'm going to put it back, though. So, my mistake was that I did not declare the kernels up here. You have to declare these so it knows that they're entry points. Also, I added these comments to clarify what texture should be set to what for each one. I think I probably was headed on a slightly incorrect path earlier, but the full res one does not have to be around until the final output. We can use threshold to read the full res one into a half res one, and that's fine, as long as we're doing UVs. And then blur back and forth should just be between two things at the same resolution. Oh, also, to target handle camera text copy. Yeah, this probably needs to be set up too. That should be okay. We release everything. We flip from the big one to camera text. It's the right size, apparently. And this, I just set up their textures ahead of time. Though the blur one is going to be screwed around with. Effectively, our threshold kernel is going to read from the actual camera texture, put that into temp1. The blur one should bounce temp1 into temp2, back and forth and back and forth. And from whatever one that ends up in, we're going to combine that with the original camera text into the camera text copy, and that should be our bloomed image, and we'll blip that in. So let me make sure we're just doing everything right now. Alright, so effectively I just changed all these threshold kernels to blur kernels, and added this little do the threshold. Also, I'm changing where this compute shader, the threshold kernel, is going to start from, because just our this is supposed to be blur kernel. So it's going to start reading from temp1 because that's where blur puts it. Let's see, blur kernel result. No, it should be it's where threshold kernel puts it. Source is camera text, result is temp1. So when we start doing blur, we start from temp1 and put it into temp2. I don't need to care about what threshold is right now, though maybe I should do that up here. Should also set intensity when I need to, but whatever. So it will blip from source to result with skip being 0.5, and we'll go from, or it's rather from temp1 to temp2. Then we'll go from, oh, no. I should keep these the same. That's result and source are skipped. Then it'll go from temp2 to temp1. That's probably that. Commenting it for now. Is this not set yet? Oh, this could be set. Let's do this up here. Okay. Width and height are also already set, right? They are not. I think I skipped a chunk, but whatever. We'll set width, height, and skip beforehand. Well, we'll start it so that we flip from, or copy from 1 to 2, then from 2 to 1. The skip should increase for this. Or you know what? It's already doing that here, right? No, this is going from 1 to 2. Fantastic. Okay. I'm just going to keep going in order. So we go from 0.5 blur to the 1.5 blur, and I need to set skip again. To the 2.5 blur. And let's make sure these line up from 1 to 2, 2 to 1, 1 to 2, 2 to 1. Okay, cool. This one is at 0.5, this one's at 1.5. This one and this one are 2.5. This is extra. This one's at 3.5. Saved in the job. Very good, very good. Now we need to do the add. And add? Pretty much. Oh, it needs intensity to be set. Come on. And then we dispatch it. And this one is a full res, so its width and height are going to be double. I have to make sure to tell it that. Anything else in here? That's good. And this should output to our text copy, which is already being put into Blit. So let's see if this thing just works. This would probably be black. So screw you. Right, threshold's probably 0 right now. That must be it. Yeah, threshold and intensity are both 0. That's speed 1. Oh, fuck. That's supposed to be 1 as well. Okay. Well, that is completely unexpected. Let's see about that. Alright, I spotted my mistake. I should have set the width and the height earlier. Okay, so let's try this. And right now, all this is doing is copying. And it is it copying successfully? I don't know if it's done. It is copying it at half resolution, but good enough for me. Let's keep that on. Sure, nothing insane is happening. Yeah, that's fine. Now let's make sure our little mathematical function works. Yep, that is basically what we want. And if you see here, if we go in color and we add some emission to this guy and screw with his colors for a second, he meets the threshold. And if we go back and we raise this threshold, eventually, no? Interesting. Except this guy's brightness too. Not very high. Okay. We do have a bit of debugging to do. Alright, now I caught my mistake. It was very silly. I passed the wrong things in the wrong order in the constructor. Now we should be able to raise the threshold, and there we go. That is basically what we wanted. Let's set this to be 1.0 for now. And we can uncomment all of our blurring stuff. And get back to this. This Big blurb. Hey, there we go. And like that, we have a functioning compute shader bloom in Unity. Isn't that prettier? On-off comparison. God, this super bright green is killing me. Let's turn that down. All right. One last thing. Let's see how the performance compares. We are currently getting around 300 FPS, and to be fair, there's a ton of background noise. I am also recording this. Ooh, that's costing us 1.3 milliseconds? 1.4 or 1.5 even. I wonder if I did something different that's way more intensive. And post-processing. Oh yeah, that's much faster. This is much faster in my other version of this. I wonder what I did differently. Okay. One last look over things before I depart. I forgot I had a debug.log in the execute function. Okay, let's try getting rid of this. Oopsie, I also changed the shader a little bit. Let's Control Z that. Let's let it recompile for a second. There we go. Now we're down to 1.8, 1.9 milliseconds. Probably costing us 0.2 milliseconds to run that. I think it goes down to 1.6. And oh, hey, look at that. The built-in bloom is around 1.92, maybe 1.8. To be fair, it does, I think, look a bit better, but goes to show you, you can seemingly do really performant stuff on your own with compute shaders in the new universal render pipeline. That is way overkill. That is too much. We should raise the threshold. If you want me to take a look at different means of doing bloom, go ahead and leave that in the comment if you have any questions or things that you're interested in. Also, go ahead and leave that. Any questions, criticism, etc. I'm also, like, I basically spent last week figuring out how to do all this, so I'm very much new to it myself. If you are a bit more experienced than me and happen to have any insights, feel free to leave them as well. And have a nice day. Oh, one last thing. Like I said before, all the resources and stuff that I learned from, I'm going to link in the comments, or sorry, in the description. And look forward to a bunch more fun topics. Hopefully less strenuous in this, a lot focusing on VFX graph and shaders.